In this video, we will solve a problem on constraint optimization. This question was asked by a brother on WhatsApp. The question is like this: let u x y is equal to minus 10 minus x whole square plus 10 minus y whole square be a utility function of some consumer. All prices are equal to 1 and income of the consumer is $40. Then optimal value of x and y will be, the options are 10 10 0 0 5 5 or none. We need to find out the optimal combinations of bundle x and y that the consumer will choose. What we are being given, basically we are being given the utility function is u of x y. That means utility is a function of two goods x and y, which is being given us as minus 10 minus x whole square plus 10 minus y whole square. Okay, prices are equal to 1. That means price of good x is 1, price of good y is also 1. Okay, so we have same unit price for good x and y. Income of the consumer is being given us as $40. We need to find out the optimal value of x and optimal value of y. Okay, so how do we solve this kind of questions? First we need to construct the budget constraint. Okay, so our budget constraint looks like this: price of x times units of x plus price of y times units of y. That means it should be equal to the total income of the consumer. That means the budget should get exhausted. Okay, total income will be spent on two goods such way that our total income will get exhausted, so nothing in terms of money will be left. So price of x is 1, price of y is 1, so in place of px we have 1, here we have also 1, so we are left with only x plus y is equal to 40. Okay, this is our utility function, this is our budget constraint. Okay, so how do we solve this? Let us border this out and also this. Now consumer will consume in such a way that the slope of the budget line, okay, should be tangent to the indifference curve. Okay, we have solved a lot of questions on this. If we have units of x on this axis, units of y on this axis, and let us say this is the budget line of the consumer. Okay, our indifference curve will look like this. Okay, so at this point where marginal rate of substitution between two goods x and y is equal to the ratio of the prices, that means price of x upon price of y. Okay, at this point we will get the optimal values of x and optimal values of y. Okay, so first order condition, for equilibrium or optimization requires that our marginal rate of substitution between good x and y should be equal to the ratio of the prices p of x upon p of y. Okay, at this point slope of the indifference curve is exactly equal to the slope of budget line. Okay, and this denotes the slope of the budget line and this denotes the slope of the indifference curve. Okay, so this is slope of budget line and this denotes the slope of indifference curve. Okay, so we are taking the absolute values obviously here. Now marginal rate of substitution between x and y simply means we need to find out the marginal utility of x upon marginal utility of y. It should be equal to price of x upon price of y. Okay, Simple funda, no bakwas. So marginal utility of x means we need to take the partial derivative of our utility function, that is uxy, with respect to x. Okay, so if we take the partial derivative of this function, what we will be left with, we can see here, or let us write it, okay, let me take here the derivative. Okay, so we have minus here. If I solve it, this will become minus 10 minus x whole square. Then this minus is multiplied to this term also. We have minus 10 minus y whole square. Okay, taking partial derivative of this with respect to x, so rather we have here this square. Okay, so if we take partial derivative of this function with respect to x, so what will we be left with? First, x is involved here, so we will use the power function rule here. That means our exponent becomes coefficient, so we have 2, uh, so this 2 becomes coefficient, so we will be left with minus 2. Then we have 10 minus x, exponent is subtracted by 1, that means 2 minus 1. Okay, and then we internally differentiate whatever is in the brackets there, and multiply to this term. So derivative of x will be here 1, so we are left with minus 1. So this is the partial derivative of this term with respect to x. Okay, then we have minus this minus. Since no x is involved here, its derivative will be 0, because we are taking the partial derivative with respect to x, so we are left with 0. Okay, similarly, so our partial derivative, rather the marginal utility of x, will be equal to uh, minus 2 x, hey, 10 minus x. Okay, 2 minus 1 is 1, and we have this minus 1 also, so minus 1 into minus 2 is plus 2. Okay, so we are left with only this term. So this is marginal utility of x. Okay, similarly we need to find out the marginal utility of y. That means taking partial derivative of this utility function with respect to y. Okay, same stuff, we have this utility function. If we want to take the partial derivative with respect to y, since no y is involved in the first term, its derivative will be 0. Then we are left with minus. Okay, using the power function rule here also, this 2 becomes coefficient, so we have minus 2. Then we have 10 minus y, exponent is subtracted by 1, that means 2 minus 1, and internally differentiate minus y, so derivative of y is 1, so we are left with minus 1. Okay, by power function rule, simply we mean x to the power n is equal to n x to the power n minus 1. If we have x to the power 6, its derivative is simply 6 becomes coefficient, we have x, 6 minus 1, that is 6x to the power 6 minus 1 is 5. Okay, so same stuff we are applying here, and also we are taking the derivative internally also. So here we have 0, so we will not write it here, so minus into minus is plus. We are left with plus 2, 10 minus y, so 2 minus 1 is 1, so we will not write it here. Now let me rub this out. Okay, so let us write here now. So marginal utility of x upon marginal utility of y will be then, marginal utility of x is 2 10 minus x, marginal utility of y we calculated, that is 2 10 minus y should be equal to price of x upon price of y. Price of x is 1, price of x y is also 1. So 1 upon 1 is 10, 10, 10, 10. So we are left with only 1. Okay, so I will write simply 1. So 2 and 2 will get cancelled. That means doing cross multiplication. Hey, meal to some is. So we have 10 minus x should be equal to 10 minus y, uh, which gives us transposing this 10 here, it will become minus. So 10 transposing this here, it becomes minus 10 is equal to, we have minus y here, transposing this, it will become plus x. So 10 minus 10 is 0, is equal to minus y plus x. Now transposing minus y here, so it becomes plus y is equal to x. Okay, simple mathematics, no bakwas here. So our x should be equal to y. Now what we need to do, so let me write it here. We just need to put this value of y is equal to x back into our budget constraint, okay, to get the optimal values of x and y. So put y is equal to x here. So in place of x, I will write as it is x plus y is equal to x. So I can write it again, x is equal to 40, which gives us x plus x is 2x is equal to 40, which implies x is equal to 40 upon 2, which gives us 2 ones are 2 20s are. That means optimal value of x is equal to 20. Okay, and let me write it here. So if x is equal to 20, which is our optimal value of a good x, then what will be the optimal value of y? Since y is equal to x, x is equal to 20, that means y is also equal to 20. So our optimal combination of good x and y will be 20 20. Okay, so the correct option should be none, and the optimal combinations will be 20 20. Okay, I hope I make myself clear in this video. Thank you.